Okay, so get this.
Okay.
Scientists are using sound waves to build organs out of living cells.
Yeah.
Not like some far-off sci-fi movie.
Right.
This is happening, like, right now.
It's pretty amazing.
Yeah, so we found this super fascinating article from the University of Melbourne
Oh, wow.
about a new bioprinter that's, like, totally blowing people's minds.
Yeah, I saw that.
And we're going to, like, unpack how this thing even works,
Okay.
why it's such a big deal for medicine, and what it could mean for the future of, well, you.
The future of you.
Exactly.
Yeah, no doubt. This new tech is a total game changer.
Okay.
I mean, it really tackles some huge roadblocks in 3D bioprinting.
Okay.
Mainly speed and precision.
Okay, so speed and precision.
Yeah.
Okay, so back up for a sec.
Okay.
I get that, like, 3D printing is a big deal, but printing organs.
Yeah.
Can you break down, like, the basics of how this bioprinting even works?
Sure. So you're probably picturing those plastic 3D printers.
Yeah.
Building things layer by layer. It's pretty similar with bioprinting.
Okay.
But instead of plastic, we're using living cells as like the building blocks.
Oh, wow. Okay.
Yeah, and the challenge is that cells are super delicate.
Yeah.
And they need to be arranged just right
Okay.
to make functional tissues.
So, like, if you don't put those cell bricks in the right place,
Yeah, exactly.
the whole structure collapses.
The whole thing falls apart, yeah.
Gotcha.
And with older bioprinters, this process was like painstakingly slow,
Really?
sometimes taking hours to build even simple structures.
Wow.
You can imagine like painstakingly placing each cell one by one with tiny tweezers.
Oh, my gosh.
It was kind of like that.
I can see why that would be a problem.
Yeah,
You're basically racing against the clock
totally.
to keep those cells alive and happy.
Yeah, you said it. It's
Yeah.
a total nail biter.
Yeah.
The longer it takes, the more those cells are at risk of dying or getting damaged.
Right.
Plus, the slow process made it really tough to position each cell exactly where it needed to be. So the resulting tissue wasn't always a reliable model of how a real organ would behave.
Okay, so enter the Melbourne team with their sound wave magic.
Yes, exactly.
Okay.
They figure out a way to use acoustic waves.
Okay.
Think high-frequency vibrations to manipulate cells.
Interesting.
Not the kind you hear, of course,
Right.
but more like using invisible, super precise tweezers to nudge each cell right into its sweet spot.
So it's like they've got this microscopic
I
orchestra,
like that.
and each cell is dancing to its own tune.
Yeah, that's a great way to visualize it.
Okay, cool.
And the results are astounding.
Okay.
We're talking 350 times faster than traditional methods.
Wow.
Structures that took hours can now be printed in seconds.
Seconds. That's got to be a huge relief for those little cells.
Oh, yeah, absolutely.
No more nail biting for the scientists either.
Exactly.
That's awesome.
This speed drastically increases cell survival rates. Plus, they've cleverly designed the system to print directly into those little lab plates. Think tiny petri dishes
Oh, shit.
where scientists grow and study cells.
So no more risky business transferring those delicate structures from one place to another.
Exactly.
A smart move.
It's a massive win for accuracy and contamination control.
For sure.
One of the lead researchers said it best.
Okay.
Just as a car requires its mechanical components to be arranged precisely for proper function, so too must the cells in our tissues be organized correctly.
Okay.
It's all about precision.
Makes sense.
Yeah,
Now, you mentioned this tech is a game changer for medicine.
right.
Where does that impact hit the hardest?
Drug discovery.
Drug discovery.
This is where things get really interesting.
Okay.
Think about it.
Okay.
More accurate tissue models mean we can test new drugs and see how they behave in a human-like environment
Okay.
without relying on animal testing.
So we can ditch those old school methods
Potentially, yeah.
and potentially find cures for diseases we thought were untreatable.
Exactly.
Because the drug development took so long.
Yeah, this new tech has the potential to fast-track the development of new therapies,
Wow.
especially for complex diseases.
Okay, so faster drug development,
Right.
potentially fewer animal trials.
Mm-hmm.
What else is on the table here?
Well, there's...
I feel like we're just scratching the surface of what this tech can do.
Yeah, we are just getting started.
Okay.
This is just the tip of the iceberg when it comes to the potential of this new technology.
Okay.
There's a lot more to uncover.
Well, I don't know about you, but I'm hooked.
Me too.
Let's dive deeper into those other applications.
Sounds good.
All right.
Let's do it.
All right, so we've established this new bioprinting tech is like speeding up drug discovery in a big way.
Yeah, definitely.
But the article hinted at some like other pretty wild applications.
It did.
So where else could this tech lead us?
Well, imagine a world
Okay.
where you could have like a tiny replica of your own organs
Ooh.
made from your own cells
Okay.
to test treatments before you even take them.
Okay.
That's the power of personalized medicine.
Hold on. You're saying doctors could test drugs on a mini version of me?
Exactly.
That's like something out of a sci-fi movie.
It sounds futuristic,
It does.
but it's becoming a reality.
Wow.
With bioprinting, doctors could potentially test the effectiveness of a drug on your unique cells
Okay.
and predict any side effects
Okay.
before you even fill a prescription.
So it's like a dress rehearsal for a drug treatment?
Pretty much.
That's incredible.
Yeah.
No more guessing games about how your body will react to medication.
Exactly.
You know exactly what to expect.
It would take the guesswork out of treatment
Right.
and make healthcare truly personalized.
Okay, cool. So personalized medicine.
Right.
But it doesn't stop there.
It doesn't stop there.
Okay, what else?
Let's talk about something even more mind-blowing.
Okay, hit me.
Organ transplantation.
Okay.
Imagine a world without organ donor waiting lists,
That would be amazing.
where you could have a new organ bioprinted on demand.
Wait, seriously?
Yeah.
Printing a whole organ?
Yeah.
How is that even possible?
We're not quite there yet,
Okay.
but this new bioprinting tech gets us closer than ever before.
Okay.
Remember, the key is precision.
Right.
To build a functional organ, you need to arrange millions, even billions of cells in a very specific, intricate 3D structure.
Oh, wow.
This new tech makes that level of precision possible.
Okay, so instead of waiting years for a donor, you could theoretically have a new organ custom printed.
Yeah, potentially.
That would be revolutionary.
It would completely change the face of healthcare,
Okay.
but it also raises some big questions.
Or what?
Who gets access to these bioprinted organs?
Okay.
How do we ensure equitable distribution?
Those are important ethical questions
They're very important.
that we'll need to address as this technology advances.
Definitely.
It's like we're on the verge of a whole new era of medicine,
It is.
but we need to make sure we navigate it responsibly.
Yeah, absolutely. Technological advancement needs to go hand in hand with ethical considerations.
I totally agree.
But there's one more area we haven't touched on yet.
Okay, what's that?
Regenerative medicine.
Oh, yeah. The article mentions something about using bioprinting to repair damaged tissues.
Yeah.
What exactly does that look like?
Think about it this way.
Okay.
Imagine printing a patch of new skin cells directly onto a burn wound.
Yeah.
Or creating a scaffold to help regrow damaged cartilage in a knee.
Okay.
This tech could revolutionize how we treat injuries and chronic conditions.
So we could potentially heal injuries faster
Yeah.
and even reverse damage that was previously considered permanent.
It's a very real possibility.
Wow.
It's like giving your body a helping hand to repair itself, using its own cells as building blocks.
That's amazing.
But as with any emerging technology, there are challenges to overcome.
Okay, let's talk about those challenges.
Okay.
We touched on the ethical considerations,
Yeah.
but what about the practical hurdles?
Yeah.
What's standing in the way of all these incredible applications becoming a reality?
Well, for starters, we need more research. We need to make sure these bioprinted tissues are safe and effective in the long term.
Right, safety first.
Exactly.
You don't want your brand new bioprinted kidney to suddenly stop working.
No, you do not.
What else do we need to figure out?
Regulation is another big one.
Okay.
Bioprinting organs raises a whole host of ethical and legal questions that we need to address.
Yeah.
Before this tech can become widely available,
Okay.
it's uncharted territory,
It is.
and we need clear guidelines to ensure responsible development and use.
It's like we're writing the rule book as we go,
Yeah,
which is exciting, but also a bit daunting.
for sure.
This technology has the potential to change everything about healthcare,
It really does.
but we need to proceed with caution.
We do.
Yeah.
It's not just about pushing the boundaries of science,
Okay.
but also about considering the broader implications for society.
This deep dive has really opened my eyes to the incredible potential and the complex challenges of bioprinting.
Yeah.
It's a lot to process.
It's a lot to take in, that's for sure.
It is.
But it's a prime example of how scientific innovation forces us to think critically about the future
Okay.
and our place in it.
So where do we go from here?
That's the big question, isn't it?
It is.
What will this technology mean for you
Okay.
and for the future of healthcare?
That's a great question, and one that I think we should keep exploring.
Yeah, definitely.
Okay, so we've covered like a lot of ground in this deep dive.
We have.
We went from the limitations of traditional bioprinting
Right.
to the mind-blowing potential of this new sound wave technology.
It's really incredible.
We talked about speeding up drug discovery,
Yeah.
personalizing your medical treatments,
Mm-hmm.
and even printing replacement organs on demand.
That's right.
Like, it's a lot to wrap your head around.
Yeah, it's a lot to process, for sure.
For sure.
It is truly remarkable how much progress has been made.
It is.
And it all stems from this one breakthrough,
Right.
the ability to manipulate cells
Mm-hmm.
with incredible precision
Yeah.
using sound waves.
It's wild.
It's like unlocking a whole new level of control over the building blocks of life.
It's like we've entered a new era
Totally.
where science fiction is becoming reality.
Yeah.
Remember that scene in Star Trek where Bones whips up a new organ in the sick bay?
Oh, yeah.
We're getting closer and closer to that.
It's amazing, isn't it?
It really is.
But with all this potential comes some big questions.
Of course.
We've touched on the ethical considerations around organ distribution
Right.
and the need for careful regulation. But what about the broader implications for society as a whole?
That's what I keep coming back to.
Yeah.
What does this mean for the future of healthcare?
It's a big question.
It is, will these bioprinted organs be available to everyone?
That's a good question.
Will they be affordable?
Right.
Or will this create a whole new level of health inequality?
Those are crucial questions that we as a society need to grapple with.
We do.
We need to ensure that this technology benefits everyone,
Yeah.
not just a select few. It's not just about scientific progress.
Right.
It's
Yeah.
about social justice and equity as well.
I agree. And we also need to consider like the long-term impact of this technology.
Yeah.
What happens when we can extend human lifespans significantly?
Exactly.
What are the social and economic implications?
Yeah.
It's a whole new frontier, and we're just beginning to explore the possibilities.
It's both exhilarating and a little bit daunting.
It is.
This one scientific breakthrough has the potential to reshape everything we know
Yeah,
about medicine health and even what it means to be human.
that's a great point.
It really is.
I think the key takeaway here is that this new bioprinting technology is like a total game changer.
It is.
It has the power to transform healthcare for the better,
Yeah.
but it also raises some really profound ethical and societal questions
Right.
that we can't afford to ignore.
I can't just focus on the science.
Right.
We need to think about the bigger picture.
Exactly, and this deep dive has certainly given me,
Yeah.
and hopefully you too, a lot to think about.
A lot to process.
We've only scratched the surface of this complex and
Yeah.
rapidly evolving field,
Right.
but hopefully you now have a better understanding of
Yeah.
just how revolutionary this new bioprinting technology truly is.
It is a testament to human ingenuity
It is.
and our relentless pursuit of knowledge.
I love that.
And it's an invitation to engage in a thoughtful and informed dialogue
Okay.
about the future we want to create.
I like that.
Yeah.
So the next time you hear about 3D bioprinting, remember that it's not just about fancy gadgets or futuristic possibilities.
Right.
It's about real-world implications
Yeah.
for your health, your life, and the future of humanity.
That's a great way to put it.
Keep exploring.